Today I have a few boards from a mass spectrometer, which I bought on eBay a long time ago, just the boards, not the whole thing. I simply purchased them because they had a lot of nice gold ceramic packages and a whole bunch of interesting stuff on them, even though obviously they're of little use because I don't have the rest of the machine. From what I can tell, according to Google, they are part of a Micromass Quattro 2 mass spectrometer. I don't have one, and I never will. This particular first board is a 4-channel A to D, and that's pretty much all that's on it. I mean, we got some relays and the A to Ds. We're gonna go through each one of these in a little more detail in a bit. I'm actually gonna break this video up into 2 parts. I'm gonna go through the chips that I open up under the microscope, and we'll take a look at those on the microscope in a different video. But this is just like a rough overview of everything. This board is just packed with stuff. A whole bunch of precision resistors and just a whole bunch of logic. This board has a couple of PGAs and even more logic, some PLDs and ceramic packages. This is the only one with indicators. It has some kind of nifty LED based displays and a whole bunch of these chips, which probably memory. And yeah, it's one of the few examples of something surface mount on any of these boards, with the exception of one of them. And yeah, this one has one of these nice NMOS chips on it. Again, we'll take a look at those in a minute. All of these boards have the same dual connector design. They also have this little red bar which you knock out the different pins to make it so only each one goes into the right slot. But this board has a big DSP and a huge analog to digital converter, which again we'll take a look at. And this board has 3 channels of something made by Specs, and they're on little pin sockets are removable, and another Specs component. This looks DAC based on the name or the part number, and more precision resistors, some potentiometers for adjustment. This is the main digital board, well, at least one of 2 of them. This one has a huge connector on it. I mean, this is insane. Look how many pins are on this thing. Luckily, the board isn't too many. I mean, it's kind of thick, but it's not too many layers. So I think that's why they were able to actually just solder this. Normally, a connector this big going through a thick board would be a press fit connector. You see those on like high-end networking equipment and stuff like that, because you just physically can't solder them reliably. So what they'll do is they'll just make perfectly shaped holes and then use special pins on the connector and just press it into the board, and it works really well. But I'm surprised they were able to actually solder these. But this one has what I presume is the main CPU of the things, Intel i960 running at 25 megahertz. This board is conformally coated, and it's kind of crappily conformally coated. I mean, it's a thick coating, so they've done a decent job on it in parts, because if you get a UV light, you can see it's just partially covering stuff. So I don't know what happened there, but it's just been splashed, and you can feel it. It's all rough because it's just drops of it. Look, it's just huge gaps. I don't know what they were thinking with that, but someone didn't do a very good job on this. Huge Siemens chips. This next board has 4 huge Xilinx FPGAs on it and a bunch of optocouplers, and again, it's conformally coated very poorly. I mean, it's just huge gaps in it. This one has a lot of like pin headers that have been crushed. It actually has a couple buttons. Oh, and it has LEDs. Okay, so they do have, oh, the other one had LEDs too, but I didn't realize that they had indicators on these ones. And yeah, some dip switches. And this last one looks like another A to D board. A whole bunch of Burr Brown parts. And whatever this one is. Oh, analog devices. Looks like probably another analog to digital converter. This one looks a little higher power. They got big tracks going to these. The first board has a whole bunch of these Burr Brown MPC 506 APs, which are 16-channel analog CMOS multiplexers. Probably taking a whole bunch of signals from inside the unit and then just outputting a data stream for the big FPGAs on the other board. This chip is a Analog Devices 574, AD574. It's a 12-bit analog to digital converter with a built-in voltage reference and a built-in clock. So it's an all-in-one unit, and it's designed to interface to an 8 or 16-bit microcontroller. The rest of it is all basically ADCs. There's a single LM311 comparator, and there's a little gal here. I think this is National Semi. And that's about it on this board. Just a whole bunch of little ceramic capacitors, and they're using Philips branded capacitors, which I don't see very often. Maybe they're bought out by someone many years ago. A little bit of information on this particular board, dated 1994 for this one. The boards have varying dates, so I'm not sure if they're from two different machines, and they, you know, these are I'm actually looking at boards from two different devices, or if they've replaced things over the years. I'm not sure. This is the main FPGA board, and this thing has these 4 huge Xilinx XC4036XLs, which are 36K gate FPGAs. They're actually kind of mid-range for the time. I'm sure they were still really expensive. And it's got a single 5K gate version. There's a smaller 32-bit PowerPC based Freescale chip, well, Motorola at the time. It's an MPC 860EN. From what I can tell, it's kind of hard to tell underneath the conformal coating. And this is a bunch of SRAM from GSI. They're 2 megabit. A 5 volt to 9 volt DC to DC converter. I have no idea what they're using this for. There's a transformer here. So does Ethernet use 9 volt? I can't remember. Maybe it does. Maybe that's what it's doing. It's just running well, it's a huge DC to DC converter to just get 9 volt for Ethernet. Whatever. I don't know what it's doing. There's another switch mode DC to DC converter here. There's a 3.3 volt one. This will be providing logic for basically everything. Since these are older FPGAs, they run on 3.3 volt logic. A whole bunch of optical couplers, probably like bus transceivers. There's a few of these really nice gold ceramic clock crystals. This one's 20 megahertz. There's a 25 and a 32. And other than that, there's not much on it. It's all just like support chips and stuff. There's some of these wide capacitors. I don't know if this is for, it's probably for minimizing inductance. And in the corner here, there's this TI part. From what I can tell, it's a NOR gate, and it's just a single one. And it's used for high current, high voltage applications. I think it can do like 30 volts or something. There's a whole bunch of little resistors there too. I don't know what they're doing with this. In addition to the tons of gold plating on the back of this board, there's a whole bunch of flash memory. This will probably have all the code for the FPGAs. Next to the little status light and a couple switches, there's a itty bitty little Max 708, which is a component monitor just to make sure everything's running properly. It'll set out an alert if there's power failure. So it'll probably just flash a little light or something should there be a failure. It looks like it's just a local thing. I don't think it's wired into anything else. There's a whole bunch of spaces for resistors and stuff here. I wonder what, oh, they populated a couple of them. I wonder what this is for, possibly configuration. This is the last of the big digital boards. This one has a bunch of these XC4013Es from Xilinx. I think these are the same series, they're just 13K gates. There's 3 of those. These Siemens chips, I cannot read the numbering off of, partially because of the conformal coating. So I'm not sure what these things are being used for. And we got an Intel i960 RISC-based CPU, 25 megahertz. This is probably the main CPU for the whole unit. It's just probably just doing management type stuff. I doubt it's handling any real data. That's why you have all the big FPGAs. Little Altera Max down at the bottom there. There's a whole bunch of switches here. These are actually like really nice switches. They're like hardcore switches. They really positively lock into place, and they're surface mount. They're used to set the RS-232 configuration from what I can tell. Single switch, redundant switch, no pull up. So they're configuring something to do with the RS-232. I'm sure one of these is like a Max 232. I just can't see it with all the conformal coding. And it looks like there's just some bus stuff, a little bit of memory. Nothing on the back on this one. This one's a little bit more interesting. This board has a whole bunch of digital analog converters on it. The gigantic ones are Sypex SP938018s, which are complete buffered 18-bit DACs. I can't imagine what that thing cost in 1997, but I'm sure it was not cheap. And they're completely integrated, so they have a voltage reference and an amplifier built in. Yeah, 18-bit DAC, not cheap at the time, and these things just pop right out. They're in nice little turn pin sockets. You can see they're just in this like really fancy hermetically sealed module, which I'm going to open up in the next video. I'll probably save a couple of these, maybe one for a collection and one throw it back on eBay. There's a whole bunch of these ceramic OP27 op amp, precision op amps. There's a whole bunch of them. There's like 7 or 8 of them on this board. And it's funny because Mouser sells the ceramic versions like these for $55. If only they were actually worth that much on eBay. There's also 4 of these Altera EP1810LC25s, which are just 900 gate EEPROM programmable logic devices. So they're actually made with some EEPROM, which you can flash and then re-record, which is pretty cool, as opposed to having an external bit of memory. These are all 0.1% accurate resistor pairs. So each one of these has a couple resistors in them. The smaller ones have 2, hence the 4 leads, and then there's a set of 4 in the big ones. And yeah, they're all made by Caddock, and I'm sure they were very expensive. In this corner, there's a couple test points marked -15, +15, and ground. There's also some probably 10 or more turn potentiometers marked start mass 1, 2, span 1 and 2. No idea what they're doing, but obviously they're adjusting various things. And as for the rest of this board, there's a whole bunch of these analog devices, AD630s, and they're modulator demodulators. Another tested sticker, 1997. This chip is an Analog Devices AD538BD, and from what I've read, this is an analog computational unit. Apparently it does multiplication, division, exponents on analog signals. It's used for computing various things like log curves and stuff like that. On this board there's a giant Analog Devices AD1376, which is a 16-bit high-speed analog to digital converter. No idea what this thing cost in 1994, but I'm sure it was a lot. Some guy's trying to sell this thing for 625 bucks. I don't think he's going to be getting it. There's a bunch of caps and other components going with it with an op amp, 15 volt rail test point there, and a little 7805 voltage regulator. This is a Texas Instruments Tms 320. It's an older 16-bit DSP. Marking 1994. A little bit more information. This is 1998 on it. So, oh, this is probably when they did the mod, which I don't know where is. I don't actually see any mods on this. It could have been something as simple as a firmware update. There's a bunch of PALs. This looks like a lattice, PALs or gals. This looks like a lattice one. There's an Altera one under here. 40 megahertz clock. Whole bunch of upside down 7.4 series logic. There's a whole bunch of SRAM, tons of it. So they're obviously taking tons and tons of data and processing it through here, because that is a whole bunch of 20 nanosecond SRAM. There's also some 45 nanosecond SRAM here from Inmos. Inmos also makes this IMST 425, which is a transputer, which you might want to just look up the Wikipedia article on. It's basically like a system on a chip design, and it uses some really weird concepts for data coming in and out, and they've got like a little article on it, and it talks about how many of its features didn't really get implemented at the time and it kind of died off. But many of its design aspects made it into modern CPUs. This is a companion chip for the transputer. This is the IMSC011, which is basically a serial to parallel converter. It links up a serial interface to the CPU with a parallel bus. This is another board that's just absolutely loaded with SRAM. There's also these Pyricom PL74FCT flip-flops. There's a whole bunch of those. This is that one board with a single surface mount device on it. It's got a DM74LS quad NAND gate, and that's it. I don't know why they couldn't get that as a DIP package, but I guess they weren't able to source it, or it's a fix of some type. In the corner, there's another one of these Max 707 monitoring chips, and it also has its own little relay, so that might be shutting off power to something or rebooting a certain chip, possibly if there's an error. This large SCN2681AC is just a big dual UART, and I guess it's interfacing with these Max 232s over here, since they seem to be trailing off towards the edge connector. It's probably interfacing with some component of the device. Who knows what it's doing? Could be interfacing with other boards, could be interfacing with individual controllers, like maybe like a barcode scanner or something on the device. There's two of these LED displays on the edge of the connector. You can see there's actually a bonded die on the right side, so they must be able to decode internally. And they have that weird pattern of PCB traces, so I'm not exactly sure what these things look like when they're lit up. I'm going to take them off the board. This looks like it might be a ROM chip, but I'm not entirely positive on that. It might be another PLD of some type, but it looks like it's probably a ROM. Luckily, it's actually just an EEPROM, so should be able to read something off this if there's anything on it. This component from IQD seems to be some kind of reference. I'm not sure if it's 1.25 megahertz or 250 megahertz. Can't really find any information on it other than the fact that IQD makes references and oscillators and stuff. It is actually a DIP package underneath. It uses a 8-pin DIP. This board has a couple more of these EEPROM PLDs from Altera. There's a couple of them. There's also a little 12-volt DC to DC converter. There are 4 channels of LM339 quad comparators, so they're, again, getting in some signal and analyzing it really quickly and probably feeding it to the FPGAs, or the PLDs, I should say. What exactly they're sending, no idea. And a bunch more solid-state relays and a proper mechanical relay up here. And these are all ULN2803s, which are Darlington transistor arrays. And there is a whole bunch of them. So they're controlling something and then reading back some information. This board is packed with both 8-bit DACs and 12-bit DACs. There's a whole bunch of them scattered around the board. There's also a whole bunch more of these 0.1% precision resistor pairs. There's quite a few of these OP471s, which are high precision, low noise op amps. They're just kind of scattered around the board. And finally, in the corner here, there's a pair of Burr Brown INA 105s, which are precision op amps. The 94 date code on this one. There's another one of these EEPROM based PLDs made by Altera, although this one's in a DIP package for some reason. And kind of tucked away in the corner is an Analog Devices 581, which is a precision temperature compensated 10-volt voltage reference. So I'll be taking that off the board. Never know when that might come in handy. This last board has a big group of solid-state relays, quite a bit of capacitance on it, bunch of trimmer pots. There's another one of these 12-bit analog to digital converters, the AD574, although this one is just in a plain normal epoxy package instead of the fancy packaging with ceramic. This large chip is a EF6821P, which is a peripheral adapter. A lot more 7.4 series logic. There's some more Burr Brown op amps. These are Analog Devices 521 precision instrument amplifiers, and there's 4 of them, and they all have these little selector switches. They all seem to be set to 3 out of the box, but they are little selectors, so I'm not sure what they're doing there. I don't know why they're all set the same. Thought maybe they'd be like channel selection or something, but not sure. whole bunch of test points. And lastly, kind of crushed inside a dip 8 socket, is a poor Burr Brown monolithic sample hold amplifier, 12-bit. This thing's proving to be a little bit resistant to my advances, so let's try filing off a corner of it. Well, you can see we're starting to get through right here, but it's going to take a little while. This isn't exactly the right file to be using for this, but it's what I could find. That should be pretty cool to look at under the microscope. Stay tuned. Although, I don't know when I'm actually going to shoot that thing, so it might be a little while, but I will make the video eventually. And there's a helicopter flying over. Ugh, you're kidding, right? Okay, at least it's leaving. The joys of living near LaGuardia.